Now let's see this question. This question came in GATE 2016 for 2 marks. The number of ways in which the numbers 1, 2, 3, 4, 5, 6, 7, that is 7 numbers, can be inserted in an empty binary search tree such that the resulting tree has a height 6. Okay? What is the height? They have said that the height of a tree with a single node is 0. So they have given the hint that how the height is calculated is that if a single node is there, then we say the height is 0. Then if a tree is something like this, then it is going to have a height 1. Similarly, this is also a tree with height 1. And if we have a tree something like this, then it has a height 2. So in this way it is calculated. So from root till the farthest leaf, that distance is actually the height. So here the distance is 1, 2. That's why the height of this tree is 2. Okay. So now let's understand that what can be the maximum height of a binary search tree having 7 nodes. Okay. So let's say if we are having 3 nodes, then what can be the maximum height? So let's say 1, 2, 3. Only these 3 nodes are there. So if we have 2 as the root node, then 1 will be here and 3 will be here. Its height is 1. But we can increase the height if we don't choose 2 as the root node. If we have something like let's say 1, 2, 3, then now we are having height 2, not 1. Similarly, we can have something like 3, 2, 1. This is also having height 2. But there can be other ways also. Something like 3, 1, 2. This is also having height 2. But this is not having height 2. This is having height 1. So the maximum height with 3 nodes can be 2. But how we are getting that? We are getting that by having a single node at every level. So at a particular level, if see at this level there are 2 nodes, right? But in these cases you see that at each level we are having just a single node. Okay, so if at a particular level if we are having a single node, then only the height is, so for n numbers the height is going to be n minus 1, then only. So for 4, if any such case is there, something like if something like this 3, 2, 4, if something like this is there, so for 4 nodes the height here is 2. But if we want to make the these 4 numbers, if we want to make height 3, then only way is that we have only a single node at each level. If we do that, then we are having total 4 nodes and there will be 3 edges possible from the root till the farthest leaf, and then the height will be 3. Okay, so that is the way. Okay, but if for 7 nodes we are talking about that if we need to have height 6, then the way it is going to have that each level is going to have only 1 node. So for 7 nodes, we are trying to calculate that in how many ways we can insert that into an empty binary search tree such that we are having height 6. So we saw that in case of 3 nodes, we saw that different possibilities are there. But let's understand it again closely, that how these are being formed. So if 3 is there and 2 is there and then 1 is there, if this is the way, then in using 3 numbers we can create a binary search tree with height 2. What about this? See, another way is 3, 1 and 2, right? Another way is 1, 2, 3. Sorry, it is going to be 2, it is going to be 3. Okay. Now another way can be something like this: 1, 2, 3. So these are the 4 ways in which three numbers 1, 2, 3 can have height 2. Now let's observe that how we are coming up with this. See, what is the order of insertion here? The order of insertion here is something like this. Firstly, we insert 3. Okay, and once we insert 3, see, we inserted 3, then we insert 2. If we insert 2, then it has to go in the left child, so it is going to be something like this. And then we insert 1, then it is going to be this side. So 3, 2, 1, actually this is the ordering. So actually whatever number is there, a single number will be there at each level, and whatever the number is there from top to down, that is going to be the order in which that is inserted. So in this case, firstly we insert 3, then we insert 1, and then we insert 2, then we will get this structure. If we insert 1 and then 3 and then 2, then we are going to have this structure. And in this case, firstly we insert 1 and then we insert 2 and then we insert 3. Okay, so these are the different trees, and these are actually the different insertion ways in which we will get these structures. Okay, so why we are doing all this? We are doing all this because for a smaller number, for a, let's say 3 numbers only, we are trying to find the structure using which these sort of trees are formed, such that at each level they are having a single number. Okay, so what we are observing here is the root node is either 3 or 1. The root node here is not 2. Why? You can understand that easily, because earlier also we mentioned that if 2 has become the root node, then we will have in either after 2 we have selected, either we do 1 or 3, or after 2 we insert 3 or 1 in any order. It doesn't matter. Let's say firstly we insert 2 and then we insert 1 and then we insert 3. Then this is the order which we have got. Let's say for this we firstly insert 2 and then we insert 3 and then we insert 1. See, we got the same tree, but the difference is that both are having height is equal to 1 only. Both are having height is equal to 1. The problem is happening because if we are choosing any element in 1, 2, 3, which is not the minimum, see, or the minimum or the maximum, then we are getting this sort of structure. Okay, so what is happening is that if we are choosing at every level, we are choosing the minimum or maximum element. So either we are choosing 3 or 1, then only we are getting this sort of structure. Otherwise, we are not going to get that structure. Okay, so for 1, 2, 3, the first node which has to be chosen is either the maximum or the minimum. We cannot choose 2. Either we choose the minimum or we choose the maximum. Once we choose the minimum, let's say we choose minimum, then whatever the remaining nodes are there, 2 and 3, again from that we have to choose minimum or maximum. There are only 2 nodes, so either we can choose 2 and then 3, or we can choose 3 and then 2, and these are corresponding to these 2 cases, right? Similarly, if in the first case we choose 3, then after that the rest 1, 2 is there, then either we can choose minimum 1 and then the other element will be 2, or we can choose the maximum. In 1 and 2, the maximum is 2 and then we choose 1. So my point is that if we are having 7 numbers, then in a similar fashion, if we have to create a binary search tree of height 6, then at each level we know that we have to choose only one node, and that node will be either the minimum or the maximum. My point is that first node has to be either 1 or 7. That's it. There is only one way. And if we have chosen 1, then after that, whatever the 6 elements are there, so 2, 3, 4, 5, 6, 7, these elements are left. Among these, in the next round, we will either choose the minimum or the maximum. In this case, the elements 1, 2, 3, 4, 5, 6 will be left. Among these 6 elements, either we can choose minimum or the maximum. Okay. Let me show you a couple of examples how this can be done. Okay. So let's say we are having 1, 2, 3, 4, 5, 6, 7. Okay. So let's say the order in which they are inserted is the same. So in the same way we are inserting that every round we are choosing the minimum element. Then the structure is going to be something like that. 1, firstly we have chosen the minimum. Among the rest, again we choose the minimum. Then 2. Among the rest, 3, 4, 5, 6, 7, again we choose the minimum. 3. In that case, we are going to have something like this, which is a tree, a binary search tree of height 6, and that is what we want, right? So we have ensured that by choosing one element at each level, but we have chosen the minimum each time. What if we choose maximum each time? So let's say the first round we choose 7. If we choose 7, then 7 is going to be here. Next we are choosing 6, then 6 is going to be here. Then we are choosing 5, then we are going to get something like this: 5, 4, 3, 2, 1. Here also the height is 6, but we have chosen each time maximum. So my point is that you can choose different ways, and let's say in 1, 2, 3, 4, 5, 6, 7, rather than choosing 1, 2, 3, 4, 5, 6, 7, rather than choosing minimum each time or maximum each time, let's understand that what if we do something like that, that firstly we choose the minimum, let's say 1. Among the rest, let's say we choose maximum. Then see how the structure is going to be different, but still the height is going to be 6. Understand why? See, we have chosen 1. Among the rest, let's say we have chosen maximum, so 7. 7 is going to be here. Among the rest, let's say we are going to choose the minimum. Among the rest, let's say again we choose minimum. And let's say again we choose minimum. Again we choose minimum. And again we choose minimum. See, here also the height is 6, but the structure is different. But it can only happen if at every level either you are choosing minimum or maximum. So here you can choose firstly 7 also, and then you can choose 1, or and then keep on choosing minimum. So here also you will get height 6. My point is that either you can choose minimum or maximum. That is the only choice. Okay. So for 7 elements, 1, 2, 3, 4, 5, 6, 7, whatever node the first we are going to choose, that is how many ways we can choose, that we can choose in 2 ways, isn't it? 1, 2, 3, 4, 5, 6, 7. Among these we can choose minimum or maximum. For the second element, whatever is going to be chosen, among the, if we choose the minimum, whatever 6 elements are there, again if we choose maximum, whatever the 6 elements are left, among them we have to choose again minimum or maximum. So if we have to choose the second element, it can be again chosen in 2 ways. Third element, again it can be chosen in 2 ways. Similarly, fourth element can be chosen in 2 ways, fifth 2 ways, sixth 2 ways. But once we have chosen the sixth element, then after that only one element is there, and then only one way it can be chosen. So overall, the number of ways in which it can be chosen is basically 2 into 2 into 2 into 2 into 2, 6 times, 3, 6 times, and then last choice is only 1. So this many ways. So actually 2 raised to the power 6 is going to be the number of ways, which is going to be 64. In 64 ways, what this can be chosen, and corresponding to each of the 64 ways we will have a different structure of the tree, but still in each and every time it is going to have height 6, and that is what we want, height 6. So total number of ways is actually 2 raised to the power 6, which is 64, and that is the answer.